Welcome to The Explainer. Today, we're going to tackle something really cool, a blueprint for building trust in a world that's designed to have none. Sounds kind of crazy, right?
I mean, seriously, think about it. How do you build trust in a system that's literally designed to trust no one? In these decentralized networks, anyone can show up. So, who do you believe? Well, we're going to break down a really elegant solution to this exact problem, and it comes from the architecture of a system called GenosDB.
So here's the plan. We'll start with the problem itself, this whole distrust paradigm. Then we'll dive into the solution, zero trust, the first user problem, where trust actually comes from, and finally, how it all creates a super resilient system.
Okay, first up, the distrust paradigm. Let's just lay out the core problem. In any of these peer-to-peer networks, you got to start with one simple kind of paranoid assumption. You can't trust anyone. You just can't assume people are who they say they are or that they're here to play nice.
So, how does GenosDB tackle this chaos? Well, it all starts with a really powerful idea: zero trust. It basically means you stop making assumptions about people and start demanding proof for everything.
And what does that actually mean? It means the system is designed to trust only one thing. Not a person, not some big central server, but pure, cold, hard math. We're talking about the unbreakable truth you get from a cryptographic signature. And this is a huge shift in how we think about truth. You know, in the old school systems, truth comes from a central server. You just have to trust the middleman. But here, truth comes from that signature. It's something each and every person can hold in their hands and verify for themselves. It's all about mathematical proof, not trusting some company.
So what you get is a system where every single person, every node, is its own security guard. You don't have to call up headquarters to ask if someone's allowed in. Nope. You check their ID, their signature, yourself. It's like the entire network becomes its own immune system, constantly checking and verifying everything.
Okay, this zero trust thing is awesome, but it creates a pretty classic puzzle, right? If everyone needs permission to do anything, well, how did the very first person get in?
Yeah, it's the ultimate chicken and the egg problem for security. But GenosDB has this really clever solution for it. They call it the welcome exception.
This is just so smart. Check this out. So a new user shows up and maybe they try to be sneaky, requesting to be an admin right away. The system just says, okay, you can do exactly one thing, create your own user account. It completely ignores the role they asked for and, bam, shoves them into the guest role. It's brilliant. The most obvious attack is shut down before it even starts.
Okay, so if everybody starts out as a powerless guest, where does the real authority come from? How does anything actually get done? Well, this is where the system gets super practical and, honestly, just makes a ton of sense.
There's no magic here. The super admins, the people with the initial power, are just defined right there in the code. It's totally transparent. Anyone can open up the code and see exactly who holds the keys to the kingdom from day one. No secrets.
And all that power they have, it's really focused on just one thing. One critical action that can't be automated, granting authority to other people. That single human decision is what kicks off the entire chain of trust for the whole system.
And this right here, this is the key to the whole thing's resilience. The super admin's power isn't in their computer. It doesn't matter if their laptop is on or off. Their power is in their private key. It's tied to that signature we talked about, which is a piece of data that can exist anywhere. So let's walk through it. Imagine a super admin wants to give user powers to someone at this address. All they do is create a little message saying that, and then they sign it with their private key. That's it. Job done. Now watch what happens next, because this is where the magic is.
So that signed message, that little piece of data, makes its way to another user. Let's call them Peer A. Peer A looks at it, checks the signature, and says, yep, this is legit, it's from a super admin, and just like that, the permission is accepted as truth. And the best part? The super admin can literally turn off their computer and go on vacation now. Their work is done.
Then, Peer A passes that same signed message on to Peer B. Peer B does the same check, verifies it, and accepts it. You see what's happening? This permission is spreading through the network, kind of like a rumor. Except it's a rumor that is 100% mathematically proven to be true. And that is why this whole thing is so unbelievably resilient.
All right, let's put all the pieces together. We've got the zero trust foundation, that clever fix for the first user problem, and this super resilient way of handling authority. So, what does that actually get us? What kind of system have we built here?
Well, we get a system that's secure by default, because it's built on pure crypto. It's pragmatic, it doesn't pretend there's no authority, it just makes it transparent. It's resilient, built for the real world where computers go offline all the time. And you know what? It's just elegant. The big idea here is that permissions aren't some command from a king. They're just another piece of signed data spreading through the network on their own.
This whole blueprint is just a fantastic example of really thoughtful security design, and it's all the work of Esteban Fuster Pazzi. It shows you how to build trust from absolute zero in the most hostile environments. It's a seriously impressive piece of thinking, and honestly, it's a model that could really change how we build the decentralized world of tomorrow.